The second approach to dealing with missing data is purification by what's called imputation. It's filling in the missing values, the question marks, with some best guess of what might have happened. I'm personally not a hoarder. I don't collect a lot of things. I don't really care about stuff that much. But when it comes to data, I really feel bad about throwing it away. I don't want to throw away data. And so going down from 9 data points to 6 data points just pains me. I don't think it's a really good idea. Imputation is an alternative to this. It's to say, okay, instead of throwing away those question marks, let's try to get a best guess of what that question mark value might be, and just fill in those values. And this is the kind of approach you might take. You take your input data, which might have some missing values in it, you take your best guess at filling in those missing values, and now you have a data set where everything has been filled in. For example, in a 9-row data set here, we had these 3 question marks, and we could say, oh, the term is unknown for these 3 question marks. I'm going to fill in those values with my best guess, which might be 3-year loan for the 3 values over here. Why did I choose 3-year loan to fill it in? Well, if you look at the original data set, there were 4 3-year loans versus 2 5-year loans. So 4 here was my best guess, and you can think about it as my best simple guess. So I just took a simple approach, just whatever was most popular, I filled those in. So the way that imputation might work in this simple approach, the rule might say for categorical data like excellent, fair, poor, 3 or 5 year, you just put in the most popular value. This is called the mode of the distribution. For numerical data, I would suggest you put in either the average or the median value. Now, these are just simple heuristics. There are many more advanced and interesting ways to impute missing values. There's something called the expectation maximization, or EM algorithm, which is an algorithm that does this in a very interesting way. Now, we just describe a very simple thing in this course. Addressing missing data by imputation has advantages and disadvantages. It's easy to understand and implement. It can be applied to any model, because after you fill in your data, you just feed into whatever learning algorithm you have. You don't have to modify anything, so that's great. And it can be used in prediction time, because whenever you hit a question mark, you fill it in the same way that you did with your training data. So if you have a question mark for term, you just fill it in 3 years, 3-year loans, just like you did in the training data. So that's great. However, imputation like this, especially simple imputation that I described, can be extremely problematic because it introduces a bias. Every question mark in term, we put it in 3 years. We didn't use any other information, we plug in the same value. And this could result into really bad systematic errors. So step back and take an example. I live in the state of Washington in the US, and let's say in the state of Washington, it's illegal to put the age into the loan application. That means that if the loan applications come from the state of Washington, age is always a question mark. In other states, maybe not a question mark, but age is always a question mark here. If you train a model across the United States, everybody from the state of Washington will have age question mark. You're going to fill in the average age into the application, let's say 40. Then you're going to believe that everybody in the state of Washington who is applying for a loan is age 40. And that's going to introduce a systematic bias into the loan applications in the state of Washington. And that's going to lead to all sorts of weird behavior, unhappy people, bad predictions, bad idea. So imputation like this has its pluses, but it's also a complicated idea because it can introduce terrible biases. So in the third part of this module, we're going to talk about an alternative that can address some of the challenges of the first 2 methods.